Hi, my name is Tor. I'm a professional drift driver and I'm a business owner at TAK Fab. Here at TAK Fab, we build some of the most winning and fastest cars in Norway. With the help of CAD and high precision fabrication, we try to push the limits on every build we do. So I partnered up with PLM Group to keep our progress and continue to develop good parts so we can keep on winning. So for the next 4 episodes, we're gonna 3D scan the engine, we're gonna do modeling in SolidWorks, perform simulation studies, 3D print prototype, as well as mount it on the car and test it on track. Hello.
Hello, Tor Arne. So this is the engine. What is the purpose of this project? What do you want to achieve?
So this is the engine we're running in our race cars. It produces 700 horsepower, 1000 Newton meters of torque. So running with such high amount of horsepower as well as grip, you get a lot of G-forces. So on these engines, we run a dry sump system. Easily explained, on an original engine, you have the oil pump here on the crank, which is pulling oil from the oil sump underneath. But while having a lot of G-forces, you will get the oil moving all the way to a side where you can get it to pump up air and air into the oil system on 700 horsepower and 7,000 RPMs will end up having a blown engine. So using a dry sump system, we have an oil pump, which we want to locate here, and the dry sump pulls the oil from a tank situated in the back of the car. So it's not any cavitated or having any air to it. And then it gets into the pump, pumps it into the engine here. And then when everything goes through the engine, through the gallery, you will end it going down in the dry sump, where it scavenges out the oil and back to the tank again. And that's why it's called the dry sump, because there's no oil in the sump, because it always gets sucked out of the engine by the oil pump.
I would think that having since you're going sideways a lot of the time and over curbs and these kind of things, it will be, I mean, having the oil pump placed so low down on the engine, it might be a possibility for it getting destroyed when you are driving.
Yeah, it's not as a big of issue, but of course the clearance of the wet sump to the ground is an issue. But the biggest concern of us is getting air into the engine.
So you would need to move the oil pump then?
Yeah, so what we do is we remove the original oil pump. We just take out the gears so there's nothing there. And then we just run an external oil pump which runs by a belt to the timing pulley.
Okay, so that's how you solve that.
Can you tell us a little bit what you got here for equipment and how we're gonna do this?
Well, today we're going to use this Peel 3D scanner, which is a light source scanner. So it works in that way that it gives like a pattern onto the surfaces, and there are cameras reading the distortion of that pattern, and based on the distortion, that tells the software what kind of digital surfaces it should build based on that. So why would we use a scanner when we are doing reverse engineering like this? Well, the reason is that if you were going to do measurements on this engine, it would take a lot of time, and you would only forget to go to the car manufacturers because they don't give out this kind of data. So being able to 3D scan it, then you will have the correct shape. I mean, we have an accuracy of 0.1 millimeters, so a point in the real model will never be more than 0.1 millimeter away from the digital model. So
wow, that's impressive.
It's quite close. So having this geometry digitalized, it will make it possible to design directly on top of that geometry, right? So you will have shapes and curves that will suit perfectly.
Yeah, because I've been trying to do my measurements, but it's a lot of angles. There's advanced geometric things on this engine, and it's nearly impossible to get everything sorted. So I can't wait to see how this 3D scanning works and Yeah, let's get to it. So Stian, how much practice do you need to use a 3D scanner?
I mean, it's really simple. You just aim and push the play button.
Okay.
And it has like this display here, so it shows whether you are too close or in the perfect distance or too far away. So it will change color based on the distance to the part. So it gives you all that you need. And it also has haptic feedback, so it gives you a little bit of vibration when you go out of focus.
Okay.
So always tell you to go back. So yeah, I mean, it's really simple.
Okay. And what kind of software, computer do you need to use a 3D scanner?
The software, I mean, the scanner ships with its own software, so you don't really need any extra software. So you have everything you need out of the box.
Yeah.
If you want to do reverse engineering, like you want to build parametric models instead of just having like a mesh model, then you have an add-in which is called pl.cad, which you can buy additionally to the main software.
Okay.
Or of course you could use a third-party software. So you get out mesh files and you could use whatever software you like for that. But the software in itself is really intuitive. This is an entry-level scanner, right? So the software is also kind of like entry-level, helping you getting started with scanning.
It's for me.
So, yeah, it's for you. or anyone else that is new to scanning. Yeah. So, I mean, there's a lot going on under the hood, which is maybe a term that you know. Yeah. But they have like closed the hood and they only show you like the things that you need to adjust. Yeah. And based on your selection, then the rest will be changed underneath.
That's cool.
So, yeah.
Let's get to scanning.